Давайте будем начинать. Всем добрый вечер. Good evening. Мы начинаем встречу очередную нашего клуба любителей Java, московского сообщества Java разработчиков. И этой встречи начинаем новый очередной сезон. Как обычно это бывает осенью. Вот. Честно говоря, мероприятие сегодня сложилось достаточно спонтанно, потому что наш гость проездом в Москве, и поэтому мы имеем такую возможность провести джук. Вот. Начну традиционно с обзора ближайших событий. Я думаю, ни для кого не секрет, что в октябре у нас два больших мероприятия, DevOps и Joker. На текущий момент программа уже вся сформирована, все докладчики на сайте. Наш сегодняшний гость не принимает участие в Джокере, к сожалению, да, принимал ранее, вот, но выступит с докладом сегодня. Что еще будет между 14 октября и 20 октября? Почему имеет смысл уехать в Питер на целую неделю? У нас будут замечательные тренинги, и у нас будет отличный джак в Питере с Венкатом. Кто не бывал на его докладах, не видел, это возможность посетить целых два доклада, один на джаге, другой на джокере. Если у вас возникнет сложность регистрации на джаг, то вы, пожалуйста, пишите. Там как-то все очень секретно, если вам не пришла ссылка в письме, то может оказаться, что вы не найдете, как зарегистрироваться. Вот, это про события. Кажется, я ни о чем не забыл или забыл. Вышла 11 Java. Кто уже обновился в продакшене на 11 Java? Есть кто? Нет? Кто планирует в ближайший год? На 8-ю? Так. То есть можно было не выпускать? И что? Не-не-не, OpenJDK ставьте, вот Чарльз может рассказать про то, как Red Hat участвует в разработке OpenJDK, то есть здесь нет никаких проблем на самом деле, и на Джокере у нас будет на эту тему дискуссия. Если вам интересно, приходите на соответствующий БОВ. Вот мы все эти вопросы, да, собираем, мы понимаем, что есть много вопросов. Но я понял, что релиз не такой уж долгожданный, наверное, да, хотя мне кажется, очень много хороших, интересных изменений, в том числе модули, да, которые были в 9, теперь они все-таки в LTS-релизе, и это окей. Про события все. Вот, я хочу представить нашего гостя, Чарльз Натер. Чарльз, вы... Чарльз разработчик из Red Hat, он участвует в разработке OpenJDK, он фаундер проекта JRuby, Java Champion. Это круто. And Ruby Hero. Соответственно, сегодня мы говорим про поддержку динамических языков JVM. Да, уже более 10 лет прошло с того, как JRuby был запущен на JVM, и сегодня мы подытожим, скажем так, текущее состояние. Да. Чарльз покажет презентацию, а во второй части небольшое демо. Вот. Как-то так. Традиционный слайд с контактами пишите по всем вопросам. Вот. Хочу сразу сказать, что мы до конца года планируем еще провести встречи. Вот, да, Влад здесь. И давайте будем начинать. Чарльз.
Добрый вечер. Мой по-русски не очень хорошо, so I'll be doing this in English. All right. So dynamic languages on the JVM. How many folks here have used a dynamic language? Ruby, Python, something like that. How many folks have used it on the JVM, including Groovy and whatnot? Okay, so we do have some folks that use dynamic languages. I'm going to talk about some of the techniques that we use in JRuby to try to optimize Ruby code. Similar techniques are used in Groovy and Nashorn and so on. We'll talk about how that's working out for us and where we might be going in the future. There's my basic information. I'm actually co-lead of JRuby since about 2006. I didn't start the project originally. It started in 2001, but really not a lot got done until 2005, 2006 when we really started working on it. I'm a kind of 50-50 between development day-to-day on JRuby and community outreach and jugs and conferences and whatnot. And I am at Red Hat. I'm very happy that they've been sponsoring the project for the past 5-6 years. And I work in a sort of research and prototyping group where we try out new technologies and play with new JVM technology and stuff. All right, so what are we going to talk about here? I'll talk about some of the challenges of bringing a dynamic language to the JVM, the problems that we run into. I'll be using JRuby primarily as the case study for how we work around those problems, how we optimize Ruby to the JVM is very similar to how Nashorn does JS and Groovy does its dynamic side as well. I'll show some of the techniques we're using. We'll go through a few interesting benchmarks, all the way from a simple numeric algorithm up to a Rails full stack database, some database requests, and see how they're looking in comparison to the standard Ruby implementation, which is written in C. And then we'll talk a little bit about the future of dynamic languages on the JVM. Okay, so what do I mean when I'm talking about dynamic languages? Well, if we compare static and dynamic languages, we can go right down the list here. So the typical thing that comes up with dynamic languages, rather than in a statically typed language where a particular call is going to have only a few known targets, a provable set of targets in a lot of cases. You know exactly what types it's being called against, what arguments are being passed. There are a limited number of methods out there that are going to fit that, and they will be dispatched directly. Whereas in a dynamic language like Ruby or Python or JavaScript, just looking at the code, even with some of the more advanced techniques we have, it's hard to tell what actually is going to be called. We need to do this lookup at runtime, ideally cache that, save some overhead in the future. In a lot of these languages, the method table where we defined all of our methods for a given class might be mutable. In Ruby, you can go in and redefine methods, you can add new methods, you can change the structure of the class hierarchy by adding in additional traits at runtime. Very different from Java, where everything is defined at compile time, and then once it's loaded into the JVM, the set of available methods stays the same. So that complicates optimizing Ruby on the JVM too. Ruby has a special issue with the structure of any given object. So fields that are defined in objects, whereas in Java you declare all of your fields up front with their specific types. In Ruby, at any time you can just assign a value to a name in an object, like it's a map. Obviously we don't want to use a map or a hash table underneath because it would be very efficient to do all objects this way, so we have to go through various techniques to optimize how we store these fields as they appear. And then the final big difference, I think, would be the compile phase, what we actually get out of compiling and starting up our code. For a language like Java or Kotlin, statically typed languages, we get a certain amount of proof that the program will start up and run and call the correct methods. Whereas in Ruby and the other dynamic languages, the compile phase, which is really the parse phase, really only tells you that the syntax is valid. You don't know that the methods are going to be calling the right things at runtime. That can end up being a little bit scary, but the dynamic language folks have also done a lot of work on testing everything, full coverage in all of their applications. So these are the real big differences between static and dynamic languages, but I think there's also some other interesting differences if we talk about languages that were designed for the JVM versus languages that have come from off the platform. So things that we've written for the JVM, like Groovy or Scala or, of course, Java, we get write once, run anywhere, but what we lose is the ability to interact with the operating system, with native libraries. Those dependencies that would not translate across platforms often are totally inaccessible to us. Whereas If you're coming from off the JVM, you have lots of C libraries and C++ libraries and different platform features that you're using more directly don't have the same limitations there. So bringing those languages to the JVM, it's a little bit tricky to support all those libraries too. Languages that are designed for the JVM, specifically dynamic languages like Groovy or Golo. If you've ever seen Golo language, is another simple dynamic language. They're designed initially for the JVM, and they tend to be designed around the limitations of the JVM. So for example, Groovy does not have the problem of treating all objects as if it was a map. They know that what the JVM wants is a specific set of fields, so that's generally how Groovy objects are defined. They've designed it to the limitations of the JVM. So it makes it easier for them to do certain optimizations. We have a lot more freedom on the off JVM languages. It makes it difficult for us to bring those languages over. Of course, JVM languages that are written for the JVM have to live within the Java world. There needs to be a compelling reason for you to not use Java. If you're already stuck on the JVM and you have the limitations of the JVM, why would you want to use Groovy over Java, for example? With the languages from off the platform, we've got an entire community. There are tens of thousands, maybe hundreds of thousands of Ruby programmers out there that aren't limited by the JVM, don't maybe use the JVM every day, except perhaps through JRuby. So we have a whole other community of people that we can draw on with new ideas and lots of new projects and things that we can leverage. Okay, I think that's covered the user-based thing as well too. All right, so here's a little grid that I've set up to kind of show where some of these languages lie. And this is in my rough estimation. So Groovy is a JVM language. It pushes the edges a little bit, so I've slid it to the right. And it is mostly dynamic. You can run Groovy in a fully dynamic mode, but most folks that I've seen write Groovy code usually will start putting static types in. It starts to look pretty much like Java with a few extra nice features. You can see where Ruby is and the challenges we have. It is very much an off-platform language. It has access to lots of C libraries. People write extensions for Ruby in C. We need to be able to support all of those sorts of features and make them work well on the JVM. Plus, as I'll show with some examples, Ruby has a lot of really dynamic features. There's no option to be statically typed. The objects might grow at runtime. The method tables are mutable. All of those things complicate bringing it to the JVM. And then there's a few other languages on here. Has anybody been playing with Rust yet? Rust is another one I think would be very interesting. I've slid this kind of to the left. It is a language from off the JVM, but it has a lot of features that would be interesting to see in JVM languages. Similarly, Kotlin I see is pushing the JVM a little bit, doing some things that are not typical for other JVM languages, but still largely a statically typed JVM language. So this is kind of the situation. Most of these languages have implementations on the JVM. Obviously, all the ones on the JVM side do. There are a couple different Visual Basic implementations. I believe some folks have done C# and F# implementations for the JVM. C++ and Rust aren't really the greatest fit because of the direct memory access, obviously. But all the dynamic languages above that line have implementations on the JVM. Of course, there's JRuby, there's Nashorn for JavaScript, there's Jython for Python. It hasn't been moving along very quickly, but it's still out there. There's even Erjang, which is an Erlang implementation for the JVM that actually supports having thousands of processes running. It uses some tricks to make that work. So why would we bother with these dynamic languages? There's all these challenges to bring them to the platform, but there are a lot of things we get out of this. So like I mentioned, we get access to a whole set of new communities. Obviously, the JavaScript community is huge. The Ruby community is huge. There's a lot of folks out there solving problems in new ways with interesting libraries. We want to be able to bring that to the JVM and have the advantage of those communities in our community as well. An example for Ruby, there's a markup and book writing or blog writing or whatever language called ASCII Doctor that's popular and is written in Ruby. Well, ASCII Doctor J, which allows you to use ASCII Doctor syntax and generate documents from it, actually just uses JRuby under the covers. It pulls ASCII Doctor, the Ruby library, and all of its dependencies in, and then runs it right on top of the JVM along with all your other stuff. So that's something that we get out of it. Of course, Rails is still a big force in Ruby web application development. Lots of new companies that are starting up want to do quick want to get going very quickly are still using Rails. Rails works great in JRuby. You can use a Rails front end, develop it like a typical Ruby Rails application, and then package it up, deploy it on a Java server with JRuby, and you've got the whole thing running together. We've got applications out there that are Rails front end with a Java backend or a Scala backend or Clojure. It all works very well together. There are also some problems that fit dynamic languages better, arguably, than statically typed languages. Building a large web application that has to be able to evolve, has to be able to change as people want new requirements. Oftentimes that's easier to do in a Ruby web development language. The popularity of Rails, and even on the JVM, the popularity of the Grails framework shows how much quicker you can get a web application up and going with some of these languages. There's also a lot we can learn from the languages, and in some cases they can be a lot more fun than writing just Java every day. Being able to switch over and use Ruby or Groovy once in a while are a nice break. All right, so let's talk specifically about JRuby at this point. So JRuby is Ruby for the JVM, and our goal is really to have it fit in as well as possible. We want it to be able to call back and forth into Java libraries. We want you to be able to deploy on Java servers, fit into the ecosystem as much as possible. So we stick within the JVM specification. We will run on OpenJ9. We'll run on different platforms. And you can deploy all the applications from Ruby just like you would any other Java app. So we are a Ruby implementation, but we have a lot of focus on the JVM platform and integrating well with it. Mostly written in Java. There are significant portions of the core of JRuby, and then the entire Ruby standard library, which we share with regular Ruby, is all written in Ruby. We're moving more and more code into Ruby as the JVMs optimize and catch up with what we need. But it's very easy for a Java developer to take a look at our code base and start making contributions right away. You can deploy it the same way that you would as CRuby. Typically, a Ruby Rails application is just a bunch of source files on your file system. Did we lose our connection?
We're going to check it, no problem.
All right. Well, I can still talk. There's nothing to see just yet, but there will be soon, so we'll have to get this. You can deploy it as CRuby folks do. Upload your files and then start up a little server application. It reads the files, deploys it, and gets it going again. All right. Do I maybe need to reconnect? Let's see if I can get that to go by myself. Looking for Apple TV. Connecting. Does not seem to want to connect. Let him deal with that. You can also deploy it as a standard Java web application. We have utilities that will take a Rails application, grab all of the Ruby dependencies, all of the JRuby dependencies, JRuby itself, of course, and create a WAR file or an executable jar file. So this is in a lot of ways better than the standard Ruby way. You can take this, you can give it to your production staff, they can throw it into the server, so you can have your Rails app right alongside all of your other Java JVM applications. We actually have had people sneak Ruby into organizations and build little applications in Ruby or Rails. They give it to their production server guys. Here it is, it's just a WAR file, and they deploy it, they never know, and they keep it secret. But I would recommend actually working with your production staff on this sort of thing. But you can do this. Yep, could not connect to Apple TV. All right, let's see. I'm going to get back into this and see what we've got next. There's JRuby review. All right, so basically JRuby is Ruby on the JVM, integrating well, trying to deploy alongside regular Java applications. So challenges of developing JRuby. Well, like I mentioned, there's all the dynamic features, the dynamic method calls, the fact that objects' shapes can change at runtime. We don't have a list of all the fields. The frequent dependencies on C libraries. So we've done a lot of work to make it easy for JRuby applications to call out to C code with just a minimum amount of work. Similar to the Java Native Access, the JNA library, we have an FFI, a Foreign Function Interface library for JRuby that lets you load up a C library, bind its functions, and start calling it. So that helps us with matching the C implementation of Ruby for compatibility and features. The other thing that comes along with a lot of dynamic languages is we have lots of little tiny transient objects. For example, all of our numbers, all of our math is done with objects, numeric objects. So imagine using big capital I integer, capital L long for all of the math that you're doing. Because it's dynamic, we need to pass everything as an object through the JVM, so that can be an overhead for us. Even beyond that, Rubyists tend to use lots of little tiny arrays and little tiny hash maps to pass information around within an application. So we need to be able to deal with all of those little objects and ideally try to get the JVM to optimize those objects away. I'll show a little bit more. And now I need a screen. Should try Connect again. Looking for Apple TV. Oh, now it's completely gone. But it's right there. Crocast. All right. Does anybody need a coffee or anything?
We're trying to get someone from help desk to fix it.
Okay.
It might take a while. Oh, here we go.
Here we go. This is the man. Seems to have gone dead. Doesn't even show up now. I'll make sure I'm still online. Yeah, seems to be working. Just chat amongst yourselves for the moment. We'll get this fixed in a minute. I can hook up directly too if necessary. It would be more reliable. Aha, he fixed it. All right, I'm just going to continue and hope nothing else happens. Okay, so let's take a little short tour of what Ruby code looks like. How many folks have used Ruby before? Okay, there's a few. So for you all, this will be review, but I will point out some of the features that make it difficult to optimize as well. So here we are defining a simple class, a person class, and calling it a class declaration is really kind of a stretch. In Ruby, what you really do is you create a new empty class object, and then it's just a mutable set of methods. You can just stick methods into it any time. So the syntax here of creating a class called person is really just creating a new class and then starting to stuff methods into it. Initialize is a common name used for all constructors in Ruby, which integrating with Java, that's been kind of no. I'm a Java guy. It would be great to be able to use this Ruby language on my Java applications, and so I went and looked to see maybe there's some sort of JRuby project out there, and it turned out that there was a JRuby already that existed. It wasn't really doing anything. It couldn't run most applications, but it had a start. And even more amazingly, a friend of mine from university was leading the project. So I emailed him and we got back together, and then for the past 12 years we've been working on JRuby together. So I like the language. I like the language a lot. And so I've gotten used to the community, and we've managed to get a lot of good uptake and adoption. We're back. Okay. So back to this example. So notice the @name here. We do assignments of it in a couple different places. This is the dynamically assigned, dynamically created fields. Notice there's no declaration of these fields anywhere else. So as these assignments come in, we have to be able to adapt the objects to all the new fields that we see. There is defining a setter method on your own. You can use equals, you can use question mark at the end for interrogative methods. But it also has a large number of metaprogramming features. So here, attr_accessor will create a setter and getter for the name field. You can do attr_reader, attr_writer if you want it to only go one way or the other. And then noting here at the bottom, there's an upcase method I'm defining on person that just forces the name to be upcased. So strings in Ruby are mutable currently. It may change in Ruby 3.0. But here it's actually changing the string content in place. And so you can imagine what sort of challenges we have when mutable strings are floating all over a highly concurrent system. So now I mentioned that basically what this is doing is just creating a new class and filling it with methods. That's semantically pretty much identical to this code. Create a new class, and then within that class, let's create a few methods. So we have these blank slates that we start out with, and then Ruby programs will fill in the methods and add the additional information. And this is a bit of Java code actually from the JRuby implementation. You can see these are the collections of methods and constants and class variables and so on. Just a map. That's actually how we represent it in JRuby. We don't have a Java class that goes along with each Ruby class. We do have actually a map, a list of all these methods, and then use various tricks to optimize getting at those methods. So I mentioned Ruby has a trait or mix-in inheritance. So here we can define a module student that defines a few more additional behaviors for a person and include it or mix it into the person class. And here, yeah, we are reopening the person class and making another change to its hierarchy. So now a person is also a student. You can think of mix-ins as sort of like an interface with all default methods. It brings this behavior along, you can pull it into your class, but it's not really part of the main hierarchy of the class. Ruby has closures, or lambdas. So here we are creating 5 people and putting them into an array. And then we have a shortcut ability at the bottom so that we can do a map or a collect iteration over all those people and call the upcase method on each one. And Ruby has this shortcut for, say, do this map and always call upcase on it. Ruby has, of course, here's more iteration, another form of doing a lambda with a do-end syntax. But it has multi-line strings, which we will get, I believe, in Java 12. Raw strings are coming along. So it has multi-line string formats, various different ways of defining strings. And you can see again here, there's interpolating person.name and person.grade into this string. And then it will print that out as it's displayed here. Now Ruby has a very rich set of ways to pass arguments. No one would ever do this all in one method, but you have standard positional arguments, the first argument, second argument, and so on. The parentheses around the B and C there means if you pass an array in that slot when you call the method, it destructures the array into the first element and the rest of the elements. So you can do very complicated destructuring of arrays that are being passed around. D = 1 there is an optional argument. And then we have similar things for keyword arguments. Key E is a required keyword argument. Key F is one that has a default value, so you wouldn't have to pass it. And then var args, essentially. Star rest will collect all of the remaining positional arguments into an array, and star key rest will collect all of the unused keyword arguments into a map, into a hash. So all of these weird different kinds of argument passing, again, complicates bringing JRuby to the JVM. We have to find efficient ways to represent this more elaborate argument structure. There's also the ability to mutate the local variables around a lambda. So whereas in Java, every variable from outside the lambda that you access has to be final or effectively final, You can't make modifications directly to those variables. It's a fairly standard thing to do in Ruby. Search through a list, find the one you're looking for, and assign it to a variable outside of that closure. Make some things more convenient. If you have multiple pieces of data on the outside that you need to update, that can be a little tricky to do with lambdas in Java. In Ruby, you just assign the variables as normal. But it does mean that when we have a closure or a lambda like this, we need a space. We need a way to call back into that previous call, update those variables. Not easy to do on the JVM. It's complicated further with some hidden variables that Ruby has. So there's this $tilde variable that holds the result of the last regular expression match. So it's kind of hidden behind the scenes. If I do a regular expression match here, that match function that it calls will actually update the caller's local variable, the $tilde local variable. The last match function can actually read that. So we need to be able to read and write across calls, even the local variables. And that makes it a little bit more complicated to bring to the JVM. We have a similar problem with Java lambdas here. So the each method here is just a standard array each. It's going to see every lambda, every closure in the system. And so if you know how the JVM works, the way it wants to see one or two methods at any given call site, the each method sees thousands of these things, thousands of different implementations. And even on standard JVMs now, we have the same issue with lambdas. You're calling into the core libraries, the core classes in the JDK to do mapping and selecting and searching through a collection. Well, everybody else is also calling those same methods. So they don't optimize as well as you'd like. We're working on ways to sort of cheat this and make those optimize better on the JVM, but it is a challenge. So this is a long way of saying that building a dynamic language, especially one as rich as Ruby on the JVM, is still a bit of a challenge. There's interesting problems to solve. And we're getting there. Things have improved greatly. But we need better tools for doing code generation, so we can create new objects for those different size fields, different shape of fields. We need better ways to optimize all of these dynamic calls and all these dynamic accesses. We need better ways to shape these objects. Ideally being able to change over time how big an object is to accommodate new fields. And then the local variable access things. Those are the big challenges that we run into. All right, so what are we doing to try and optimize JRuby? Well, we are focused very much on running across JVMs. There are new technologies, new ways of doing optimization of languages, like Oracle's working on their Graal VM. We focus on running across JVMs, and so only what we can do within the JVM spec, basically. And we do actually run very well on OpenJ9. We run on all the different platforms that have JVMs, which is pretty much every platform you care about. We've got people running on OpenVMS and AS400 and ZLinux and all sorts of weird platforms that even CRuby doesn't support. We have been supporting all versions of Java since 1.4. These days, we require Java 8 or higher. How many folks are still using Java 8? I think I heard some discussion about this earlier. Yeah. 9? 10? There are a few. 11? Anybody made the jump? Yeah, I didn't think so. It's going to be a while for the module stuff to really catch up. We're still working on module support, even though it's a whole year old at this point. I can't believe it's just been a year since 9. So yes, like I said, working largely within the bounds of the JVM specification. So without any modification, we can take JRuby, run it across platforms and across runtimes. We do have to hack around the JVM in some ways. Like I mentioned, the Lambda inlining, the Lambda optimization problem. We may regenerate a new version of each for all those different things to try and force the JVM to optimize. But still running within the JVM spec and not cheating too badly. Lots of different experiments that I'll mention here. So one of the first things that we do to try and optimize JRuby and make it run well on the JVM is that we actually have our own JIT, our own just-in-time compiler within JRuby. Nashorn had the early experiment. Every piece of JavaScript code that came into the system, they would immediately compile into JVM bytecode. Well, with a very large JavaScript application, all just source files on disk, that is a huge hit to try and start that application up, do all the compilation, throw all this bytecode at the JVM, and then hope that things start optimizing and running pretty quickly. Really bad startup time for Nashorn when they did it that way. We knew that this was going to be a problem, so we've always had both an interpreter for Ruby code and a compiler to JVM bytecode, a JIT, that actually runs later on. So the code starts up, it compiles into our intermediate representation, our IR, and then we have a simple interpreter that runs through that code and can get it executing as quickly as possible. As it runs, we can do additional static optimizations. We do have some profile-driven optimizations, meaning that our interpreter will watch how the code is executing and then make better versions of that code. Then the JIT will eventually kick in and either transition all the way to JVM bytecode using the optimized version of our IR, or we also have an optimized interpreter. If we don't want to throw too much bytecode at the JVM, we can back off a little bit and still run the optimized code in a second interpreter we have. So we're actually like a 3-tiered JIT on top of the JVM's JIT. It's like building a little runtime on top of a big one. So there's other pieces that we want to work on here. Being able to do more speculative optimization, like say, okay, it looks like they're calling each here. It's probably an array each. Let's optimize it as if it's an array each and back off later. We can't do that just yet, but we do have prototype code that will allow us to be more aggressive in optimizing code. We lean on the JVM a lot here, and we need to give the JVM a little more help. So here is kind of a diagram of how the IR works internally. Originally, in JRuby 1.7 timeframe, we just had an AST, and we parsed it to the AST. The interpreter was just walking through the AST nodes and executing them. Very simple, like a first year computer science interpreter of Ruby code. Now we have a much more standard compiler for Ruby code that will eliminate dead code, it'll do optimizations. So we do our semantic analysis, turn that into IR, and we have our control flow graph, our data flow graph, all the stuff that you guys learned in university if you did any compiler work. I did not take compilers. We had a friend come in and work on writing a lot of this stuff for us. So then finally we will interpret that IR or generate bytecode and so on. Here's an example of some of our IR instructions for a simple Ruby method. It's pretty easy to read, this format. So we check and make sure we've received one argument. That's our arity check at the top. We assign some hidden variables like the self or the this variable. We receive that argument into the b variable. We're going to call equals with a fixed num, which is Ruby's long, a fixed num 1. We are doing a branch there, and then you can see the rest of the code. We either print out the 1 or we print out 2, or we print out not 1 here. We actually plug into a tool that the JVM folks use called the Ideal Graph Visualizer. They use that to look at the internal structure of JVM's optimization. We can hook up to it and see the internal structure of JRuby optimization in much the same way. So we have our instructions here, we have methods off to the side that we can see that have been loaded into the system, we can see our control flow graph, and then we can see the different optimization passes in JRuby's compiler and see what's happened to the code at each step. So here we have a dead code elimination pass where we're removing some code that's never been executed. So here's there's code up at the top that's been added by the optimizer and code at the bottom here that's been removed. It was proven that we wouldn't actually call it. So that's on the runtime level, the execution of Ruby code. Object shaping. The whole issue of having all these fields, we are actually working on trying to optimize this as well. Currently, the way we do it, we statically will look through all of the methods in a given class and inspect to see whether they're assigning any fields, any new fields that we haven't seen before. Based on that, at runtime, we will generate this right size object for all of those fields, and then use some mapping logic to make sure we know where to assign it, how to optimize them. If we can't make any determination, or if there's new fields that come in after that point, we do still fall back on just an array of values. But for a lot of objects, a large portion of objects in the system, they will be packed tight and they will use less memory as a result. I will talk a little bit more about InvokeDynamic a little later, but we use InvokeDynamic, which came with Java 7. We use InvokeDynamic to directly access those fields. So a simple enough or a Ruby application that maps well and has a standard set of fields in each object will be very similar in performance and memory usage to a standard Java application, standard Java objects. So this is actually working pretty well for us. Much less memory used than having this array and so on, and less indirection. We don't support any primitives in here, but we are working on that. So if it looks like one of those fields is always being assigned a fixed num, we could make it a little bit more efficient, always store it as a long, save the memory of having those objects around. And currently, once we've made the determination of the shape of that object, it's that shape forever. And anything new will just fall over into that array. We want to be able to improve that over time. So as new fields come in, maybe it goes from Ruby object with 2 fields to a Ruby object with 3 fields and adapts as the system goes on. That's all upcoming work. So here's a bench of just doing a simple select, active record select in Rails. Active record is their ORM for the Rails framework. And you can see there's still a large number up at the top, large number of objects that are using iRuby object array. Some of these are passing arguments on a call on the actual call side, but a lot of these are objects we couldn't see how many fields there were. So a lot of dynamic code creation, a lot of magic in Rails. So there's still a number of objects that don't adapt properly. But there are tens of thousands, hundreds of thousands of objects out of this set that are being optimized to their correct size. So this is working pretty well for us. We do a similar thing for arrays. There are lots and lots of little tiny arrays floating around in a typical Ruby application. 1 and 2 and 3 element arrays just used for convenience purposes, passing multiple arguments in a single slot. So we have our standard array class, or the array is essentially a list. We have our standard array class that has an actual Java array inside of it, similar to an array list. But we also have an array with 1 element and an array with 2 element. So they use actual Java fields, reducing that cost. We don't have to allocate the array, we don't have the extra indirection. For the same reason as the object shaping helps us, this helps us do a little bit more efficient job. Now we need to unify these two. We need to bring the object shaping and array shaping together into a single piece of code so that we can do the primitive support and all that alongside it. But this is actually working pretty well. In that same benchmark, I checked to see how many arrays are being created, and nearly half of all arrays, all the lists created in a typical Rails application are these 1 and 2 element little arrays. So just by doing a little hand specialization, we've actually cut the memory usage on those down significantly. All right, I mentioned InvokeDynamic briefly. So we worked very closely with Sun Microsystems then and Oracle now to make InvokeDynamic optimize JRuby very well. We use it for all of these dynamic things you see, for method calls, for doing field accesses, even for looking up a constant, looking up the name person, for example, and finding the class that goes along with it. All InvokeDynamic. If you look at JVM or JRuby's bytecode, it's basically just InvokeDynamic after InvokeDynamic the whole way down. So we need the JVM to optimize this stuff, and it looks like it's doing pretty well. It does have somewhat of a startup time impact, which is worse on Java 7 or 8, but improving over time. We're getting to the point now where we can just use InvokeDynamic exclusively and shouldn't have any startup time issues. We want to do a little bit smarter job of using InvokeDynamic so that, for example, if you're always allocating a 3-element array at this point, we'll optimize that code. InvokeDynamic knows to do the 3-element array version. And like I said, the each problem, the lambda inlining problem, doing some more work to clone those methods so that they'll optimize well. Currently, because of that startup time issue, you would have to turn InvokeDynamic on in JRuby to get full speed performance out of it. But then you can see we've got our Ruby script and eventually calls this foo method I defined. It's all InvokeDynamic, all lambda form stuff. The internal stuff, internal guts of InvokeDynamic is all that exists between there. And the JVM can see through all of this and optimize it as if it was a standard static call, like a regular Java to Java call. I mentioned being able to access variables, local variables across calls. We have various tricks for doing this. I won't go too into depth in this because it's kind of weird compiler stuff that we're working on. But we try to prepare that location, that special variable $tilde, only when it looks like we're going to need it. And so we have various tricks to try and see, is it going on regular expression match? Is it calling one of these methods that's known to access the caller's local variables? And then only do it when it's required. We have other plans here to back off and be able to de-optimize when we make the wrong decision. So if you actually are calling one of those regular expression methods and we didn't guess it right, you would back off and it would still be able to work properly. There's also the Stack Walker API, which I think came along in Java 9. And it's used for basically looking on the call stack in a read-only fashion to see who called me and who called that method and who called that method. There is a trick, a secret backend to the Stack Walker stuff that lets you actually write to those frames. So we may be able to use Stack Walker in the future to do those updates without allocating a separate object on the heap. We'll actually go back and change local variables on the stack. And then the final area we're looking at is just using newer JVMs, better JIT optimizations that are coming along. We've started to explore the non-hotspot JITs, the non-hotspot runtimes like OpenJ9. We have people running on OpenJ9. We're looking at it more now for performance purposes. Also Azul's Zing, which now has an LLVM-based JIT. So we're very interested in trying that out. We're just getting started on that. The Graal JIT is now available as part of a standard JVM in Java 11. And as I'll show later, it's showing some very good performance characteristics for dynamic languages. We're excited to play with it more. There's also this non-JVM Graal VM that Oracle seems to be working on. Also, again, shows promise. It's based on the Graal JIT, and we're excited to see what we can get out of that. So we've kind of had mixed results, but we're working with these different teams to try and make sure JRuby runs well. We're a great test case for InvokeDynamic and JVMs, so they want to try and run JRuby and make sure they're doing the best they can. Above all, though, we want to stay a JVM language. So even though we want to support all these different runtimes, and some of them may have significantly better performance, like the Graal JIT, we will always still support standard JVMs and want to run well everywhere we can. So we'll do whatever tricks we need to. So I mentioned Graal VM. There's also another framework that comes along with that called Truffle that I thought I should mention quickly. So the Truffle framework has a lot of nice features for building dynamic languages. Rather than writing your own JIT and your own bytecode execution or your own bytecode compiler, you just implement the AST. The AST interpreter actually then feeds into the Graal VM and optimizes the code for you. Just requires some annotation, mark it up a little bit, and then it gets a lot of good performance out of it. It has its own object shaping, object specialization with this dynamic object that's built into the Truffle framework, so they get that for free. And then they have a much better way of communicating optimization tricks. I need these methods to always inline. I need to be able to de-optimize this code if something goes wrong. We have to try and hint to the JVM that we want things to optimize and then hope and pray that it actually does it. They can actually tell the JIT to do it, which is nice. And then all of the Truffle languages integrate very well together. So you can call from Ruby into JavaScript and so on, and they should optimize together. And of course there is a Ruby implementation that Oracle has been working on called Truffle Ruby. Cool thing here is that most of their core classes, most of the core of Truffle Ruby is implemented in pure Ruby. We are getting to that point, but the JVMs haven't quite caught up with us. It is extremely dependent on the Graal framework. It will not run well on anything other than Graal VM or Graal JIT. They're doing very good as far as their completeness. They're even supporting those C extensions that I mentioned for the standard C Ruby implementation, but it's still very early days. Performance-wise, some of those things don't run so well, and they are continuing to work on optimization. I bring up Truffle mainly to say why we're not using Truffle at this point. Like I said, we support Java 8. On a Java implementation that doesn't have Graal, Truffle just does not work, unusably slow to run Truffle Ruby on anything other than Graal-based runtimes. It's been about 5 years and they're still working the kinks out of this thing. We're hoping that maybe they'll solve those issues and then we can just take Truffle Ruby and use it as part of JRuby 2. There's no supported production-ready runtime yet. It's always been like next year maybe it'll be ready for applications. We also have suspect that maybe their integration with Java might be a little bit more cumbersome. That dynamic object does not look a lot like other Java objects. So those are some reasons why we've not focused on it. Oh, and this, I hate this build. So this is the other reason why we don't use Truffle. We have tons of production users out there already. There's no way we're going to be able to get them to switch to this new experimental runtime. And probably just some folks you'll recognize on here, BBC News, for example, all of the election results in the UK is actually delivered as a Ruby application, JRuby application. NASA uses it for coordinating, I was trying to think of what it was, the Allen Telescope Array in California that's used for the SETI project, the search for extraterrestrial life. I'm not sure if it's still this way, but actually JRuby was coordinating all of the telescopes. They've got native libraries that actually like move the telescope and point it at particular spots in the sky, but integrating all that is actually a JRuby application, which is pretty cool. Like JRuby might help find extraterrestrial life. I like that one a lot. And then there's a bunch of other ones on here, of course. Square has built a lot of stuff on Ruby. So we have a huge existing user base that we need to support. We will explore Truffle and those technologies as it becomes feasible for us to do so. Okay, oh, and one more. All right, so what can we do? What are we doing as far as on the JVM side? Well, we'll continue to work within the bounds of the JVM. We want some of the features that Truffle has at the JVM level. So we will continue to work with the JSR folks, with the OpenJDK people, to build those features as standard Java capabilities. We want to be able to run on all JVMs. We don't want to just depend on Truffle and Graal. And then we'll continue to try and trick the JVM into doing what we want right now. But we've always focused on real-world users, what they're actually running, what performance they actually need out of their application, and we'll keep our options open. Okay, so the final section here, let's actually talk about what the performance looks like for JRuby with all of these tricks that we've put in place. I've got a few different examples here, numerics, some simple data structures all the way up to a Rails database access, which is a huge amount of Ruby code. I'm going to show examples on C2, which is the standard hotspot JIT, versus the Graal JIT that we have in Java 11, that you can turn on in Java 11 at least, and the new Graal VM as well. I will show CRuby performance and a little bit of Truffle Ruby performance for some of these to show that we're actually significantly better than CRuby and pretty much competitive with Truffle Ruby on these particular benchmarks. Okay, and CRuby actually is working on a JIT. I did not include that here because it does not appear to help most of these numbers right now. It's early days. All right, so numeric algorithms. We don't use Fibonacci anymore. We use the much more useful Mandelbrot generator. For all of those folks doing their startup that just does Mandelbrot, we'll be really ready for your applications to run well. Just a simple fractal generator just dumps it out at the command line and you time how long it takes to do each of these iterations. It's kind of a worst case scenario for us. There's lots and lots of numeric objects being created, so there's lots of boxed numbers, lots of fixed num objects and float objects that are floating around. CRuby has tricks that they can use to not actually pass objects. They use something called tagged pointers. And Truffle Ruby actually is able to specialize more code, so they can use longs and floats, primitive values. We're working on doing that similar sort of specialization too. But as you'll see, we get a lot of help just from running on the Graal JIT. Here's the Ruby code for this Mandelbrot generator. You can see lots of math here. All objects being created. Every time we have a new number, it's a new object in the system. And so that's a lot of object to be allocating, a lot of object to be garbage collecting. We need the JVMs to do a better job of eliminating those objects. So let's see how this looks. So here's CRuby 2.5 results. I mentioned that there is a JIT. It improves this very slightly, but that's about where they're at right now, 3.5 seconds or so. So JRuby just running on Java 8 with the standard hotspot C2 JIT compiler, much faster than CRuby already. The JVM optimizations are really working for us here. InvokeDynamic is doing a lot. But we are still creating all of those objects. We have the overhead of the boxing. Now, the really awesome thing is if we start running with the Graal JIT, which is available in Java 11, it drops down significantly. I can take a look at this assembly code for this Mandelbrot generator for other numeric algorithms, and it's actually almost the same code that Java would be with primitives. The objects are getting eliminated. It's optimizing it like it would for a regular Java application with primitive values. So that's very exciting. How does this compare with Truffle Ruby? Truffle Ruby's talking about their performance. They're very impressive in a lot of things. So there's our graal JIT numbers, which I call graal CE here because it's the free one that's in OpenJDK. There's also a closed source graal JIT in the graal VM. Helps a little bit, not a significant change here. The regular graal JIT is doing well for us. Truffle Ruby, again, just slightly faster here, and actually loses some performance on EE for some reason. But all of these numbers largely in the same area. So with a pretty standard JVM language implementation, JRuby, with InvokeDynamic, with all these boxed numbers, if we use a better JIT, we can compete with some of the newest, fanciest technologies for writing languages on the JVM. So that's pretty exciting. We don't need to use Truffle to get this kind of performance. And we can start to do this on all the other VMs as well. So here I show some silly Ruby tricks that people do. This example, rather than using A greater than B and then deciding which one's larger to define a max, for example, Rubyists might say create a little array with those two values, sort them, and take the first one. Much more complicated way to do it, but it's kind of a Rubyism that you see once in a while. So lots of little arrays, little hashes being passed around just for convenience purposes. These aren't common tricks, but they do come up. Once in a while, they'll come up in hot code, hot paths. So we would want to be able to eliminate that array, optimize that sort, and try to make it basically the same performance as a standard version with the less than method. Truffle Ruby does very well here because they can eliminate those objects, inline the sort much better. But we're interested right now in seeing what JRuby looks like on C2 versus graal here. So here are the three different versions. The normal version that just uses the typical code, the version that uses an array, and a version that has a var args that's passed in. So you pass both values, it turns it into array, and then does the same logic. Here's what the performance looks like for these. As you'd expect, the normal version of this does much better, optimizing wise. So this is in iterations per second, so higher bars would be better performance. Graal here is actually optimizing the benchmark itself significantly better than hotspot C2. For whatever reason, graal E seems to have some trouble with the normal version, doesn't optimize the right way. Well, we'll take the normal version out and look at these array and var args versions. We can see that the graal JIT helps quite a bit. It is actually eliminating some of those intermediate array objects. If we go to the closed source graal, it's even more than that. So it's very exciting to see what's coming along. A little bit more practical version, a little more practical demonstration here, a red-black tree. So there's an implementation of red-black tree purely in Ruby. We've actually compared this with JRuby running the C extension red-black tree and can beat them on the performance. Because of the way the JVM optimizes, because all the extra Ruby code inlines and optimizes well, we can be almost as fast as a C implementation of a red-black tree. So the remaining work here is to try and get rid of some of those objects and eliminate some of the cross-method call local variable stuff. Here is bits and pieces of this red-black implementation. Lots of constants, tons of methods, lots of different fields. Something else you'll see in Ruby, very large methods that we have to be able to optimize well, break them up into pieces and then compile the pieces separately. But the interesting bit here is down at the bottom we've got our benchmark where we're just going to create a big tree, we're going to add a bunch of elements to it, we're going to delete some, search through it, various red-black operations, and then do this in a tight loop to see how fast we can get this to run. So red-black execution. Here is JRuby, as I mentioned, 1.2 seconds or so for this particular benchmark. And this is JRuby running the pure Ruby version. It's a bit faster with the C version. JRuby on Java 8, standard hotspot C2, 0.4 seconds. So 3 times faster, or 3 times faster than JRuby just by running on a standard C2. Now, oddly enough, the graal JIT here does not help us as much. It's not seeing the right optimizations. This is the sort of thing we go back to the graal team and say, we need to get better performance out of this. We need to optimize better. Something's not working the way we want it to. And as I mentioned, Truffle Ruby does pretty well on this. They get good performance boost out of both of the different graal JITs. So it should be possible for us to match that. We need to figure out why it's not doing what we want, why it's not optimizing the right way. And so finally, active record. So as I mentioned, this is Rails database layer, their ORM. It's definitely the largest part of a Ruby application. That's where almost all of your performance is going. If you can't run active record fast, you can't run a Rails application fast. You can use other database frameworks, of course, but most Rails applications are built on active record. It is a huge amount of Ruby code. We support the backends for SQLite, MySQL, and Postgres, and then there's a huge amount of code on top of that in pure Ruby for building the queries, doing the integration with the database, and creating all of the objects and so on. So it's a very heavy Ruby example. This is a lot of Ruby code and a good example of how JRuby is actually optimizing well. Here is basically comparing JRuby on the different JITs with CRuby. We were very excited about this year because this is the first time in the past year that JRuby has been significantly faster than CRuby on active record queries. So for the first time we can say without a doubt that JRuby is the fastest way to run Rails applications, which is cool. And that's comparing to a C implementation. We're just a plain old JVM implementation. Graal JIT here doesn't give us a whole lot of help. So we kind of expected this. There's a ton of objects being created. There's a lot of interaction with the database. Those are things that the Graal JIT is not particularly good at for this stuff. The warm-up curve here. So here we show that the C2 JIT is kind of middle of the pack. Graal is actually doing a pretty good job of warming up reasonably quickly. The closed source, the enterprise Graal JIT takes a little bit longer to get going, but eventually does have the same performance. This is actually an interesting one on the Truffle Ruby side. They start out much slower than us, and it takes them a little bit longer to get down to peak performance for Rails stuff. So our conservative approach of building our own JIT, eventually turning it into bytecode, seems to be working well to get applications up and going quickly. All right, so a few final notes here. Hopefully you've seen that there's a lot of challenges to implementing Ruby, but we're doing a lot of good work. We're making a lot of strides to optimize that code, especially those simple numeric algorithms have come a long way in the past couple of years. We're going to continue to use InvokeDynamic better and do better shaping and specialization of objects so we can have primitives in the right size and the right shape and everything. We obviously have a lot more that can be done at the JVM JIT level. The Graal JIT is the first one that has this, they call it partial escape analysis feature that eliminates all of those numeric objects. That's what's making the Mandelbrot and the other numeric stuff run so fast. We need to see the other JVM JITs add this. We need this in J9, we need this in Azul Zing. Right now they don't do as good a job on those sort of things. So we're hoping to see the other JVM JITs catch up on this too. Even still, performance on just a standard Java 8, which is several years old now, is significantly better than CRuby. The fastest way to run Ruby applications is JRuby, so I think we're doing a pretty good job. And I'm excited about what we can do in the future. All right, and that's all I've got for slides today. Thank you.
Okay.
Yeah.
Well, I'm not that familiar with what is going on in Ruby community, so I would like to ask how fast is Ruby language developing, and how do you catch up with new specifications?
All right, good question.
Because I'm using Jython and they got great problems with this each leg.
Right. Yes, so the question being keeping up with Ruby, how fast they're moving just to keep compatibility up. We had troubles with this. It took a long time for us to catch up. We were several versions behind for many years, but about 2 years ago we released JRuby 9.0, and at that point we finally managed to completely catch up with them. That was a Ruby 2.3 compatible. We released it about 6 months after Ruby 2.3 came out. Since then, we have spent a lot more time and focus on keeping up with it. Ruby 2.5 came out just this past December. In April or May, we released JRuby with Ruby 2.5 support. Ruby 2.6 will come out again this year. They are moving fairly quickly. Not a huge amount of language changes, but internals with arrays and new utility methods. So the lag right now is only 4 to 6 months or so for us to catch up all the same features. We kind of let them finish it up towards the end of the year. We start looking at it and then do the work for the next 5 or 6 months to catch back up. It's unfortunate that Jython has not really managed to find funding to keep working on it. That's really what almost all of our time is doing. Red Hat funds, there's just 2 of us that work full-time on JRuby, and we split our time between community and optimization and compatibility work. So I'd say 60 to 70% of our time is spent on fixing existing issues and matching new features. But we are keeping up. Thanks. Anything else?
Can you tell us any success stories about companies who use JRuby for their products and their experience?
Sure, absolutely. Well, so there's one, I can't say the company name, but one of the things that they did was they realized they had a huge Ruby Rails application. I believe it was a Rails application. A huge Rails application running on AWS, and they were running something like 35 C2 extra large instances, which that adds up. That's a lot of money to spend on those servers. At that point, it became worthwhile for them to say, maybe we should do the extra work, which I think was only about a month's worth of work, to translate it over, swap out a few libraries, and run on JRuby. Their success story was that they went from 35 extra large instances on EC2 down to 10 mediums. This is tens of thousands of dollars they're saving every month in hosting. So that was a huge gain for them. We just utilized resources better, we optimized better, they didn't need as much hardware to run us. Other success stories, Square, for example, in California, they started out with Ruby and JRuby very early on. I don't know how much JRuby they have left in their system. I don't know how much Ruby they actually have left in their system, but they're an example of where JRuby really helped them get up and going. For a long time, for several years, every transaction that went through Square was passing through multiple JRuby applications in the back end. A similar case, GitHub's enterprise product initially was launched as a JRuby application because it was easy for them to just give a WAR file to a company and they can deploy it. They eventually moved away from JRuby because they needed tighter integration with native libraries and CRuby stuff. But again, we helped them launch that product essentially just by having JRuby around. So there's a lot of these. We're really excited about the folks using JRuby. Okay, we'll go with you first.
There's a bunch of new languages today. And do you recommend start new project in Ruby or JRuby?
Right, lots of new languages to choose from. Yes, if you're interested in doing a Ruby application, so there's 2 halves to this question. First of all, would I recommend using Ruby or Rails for a new application? Absolutely. I've seen how quickly companies can get an application up and going in Rails, and you can literally have something out in production within a day. A very quick way to get applications up and going. And then continue to evolve it very quickly over time. If you expect this thing to ever scale to a large size, starting out on JRuby from day 1 is definitely the easiest way to go. If you start out with regular CRuby, over time dependencies creep in, dependence on certain bugs in CRuby. We try to be bug for bug compatible with CRuby, but there's always little quirks that someone will find and then your application doesn't work. So yes, I would say it's worth looking at Rails and Ruby for doing new applications today, and if you're doing so, strongly recommend starting out on JRuby. Yeah.
The main use case is web application.
That's still the big thing. That's the killer app for Ruby still these days. Rails applications. There's also some smaller web frameworks. There's one called Sinatra, which is really good for small microservice sort of things. And we run Sinatra and those microservice sort of apps extremely well. That's a similar sort of case with the 35 extra large down to 10 medium. We can really scale those up very well. And then nowadays Rails looking much better. But it is still mostly web application development and some microservice stuff. Let's see, that was another question back here somewhere. You can go ahead. Sure.
How does Java model system impact dynamic languages? You've done some research in this.
How does what impact it?
Java model system.
Yes. Java module system, how does that impact this? Optimization-wise, I haven't seen it have any real effect. Most of those security checks and whatnot are done once at boot time or when you first call something. Where it affects us more, we have had to use a lot of reflection tricks to get compatibility to match JRuby. For example, we actually need access to a native file descriptor in certain places. So we use reflection to dig the actual file descriptor out of a Java stream. That gets a little harder to do with modules. We are currently working on modularizing JRuby itself so that we could say, okay, well, JRuby needs to be able to reflect into file channel. So add this flag to our runtime, add the flag to start up so that those are available. But mostly the impact for modules right now is on what level of compatibility we can have with JRuby. It's all stuff we can work around, but if you were to start with JRuby today on Java 9 or higher, you might run into some compatibility issues compared with JRuby. On 8 it should all be great though. Yeah?
I wonder how Java features map to JRuby features. Like, can you use Java Lambda instead of JRuby Lambda? Do they have something in common? And the same question about string and other things.
Right, okay. So how about integrating with Java, going back and forth, the way features map together? So just creating Java objects, accessing Java classes, calling methods, it looks just like regular Ruby code. You just .new an array list, you can call into all the methods. We do all the magic behind the scenes of passing stuff back and forth. For what we would consider the core types, the primitive types of Ruby, which would be numeric objects and strings, we will translate that back and forth. So our fixed num object can be used to call any integer method. Our float objects can be used to call any double or float methods on the JVM, and strings will translate back and forth. All of our strings are actually UTF-8 internally, so generally we need to transcode or turn it into a Java UTF-16 string. This is improved with Java 8, where it can actually represent UTF, or at least ASCII as a more efficient format inside strings, but we still do translate back and forth across that boundary. Otherwise, you can just call into regular methods, you can pass objects around, and the Java objects just live right alongside the Ruby objects. Lambdas, let's see, I think we have an open issue for this. A Ruby Lambda should be able to pass anywhere that a Java Lambda exists. The tricky bit we don't have done just yet is adapting it to whatever that interface is that you're calling against. We've actually been doing this on our own long before Java Lambdas. So you could say, if I can show a demo later, if you were doing swing and you did an add action listener, you can do add action listener with a Ruby Lambda, and it will work. It'll actually be an action listener and implement the interface. So it works for most of those cases, but there's more integration with Lambdas that we need to do. Other Java stuff, most things work pretty well. If you have a Ruby object that you want Java to see, you can implement a Java interface. That's the way we would recommend doing it. And then that Ruby object will actually be that interface, list or map or whatever. When you pass it out to Java, it has no idea that there's Ruby under the covers. It looks just like a regular Java object. We can extend Java objects, but it's a little bit trickier because we have our own object hierarchy. But you can extend Java objects and live within that hierarchy too. So most things work pretty well across that boundary.
And I have another question
Mm-hmm.
about performance. When I was using Ruby, there was a popular thing, I think it was Iron Ruby, which was like 20% faster than the standard implementation.
Right.
So did you compare JRuby to one of those?
Yes, so excluding Truffle Ruby, which is really fast sometimes and not really production ready other times and so on, JRuby is definitely the best performing production ready Ruby implementation. There are a lot of experimental ones, like there was Topaz that was implemented with PyPy technologies. There was Iron Ruby on the CLR runtime, which doesn't really exist. I mean, obviously .NET exists, but Iron Ruby is not being worked on anymore. We have been faster than all of the ones that were production ready, and really, there's only been 2 or 3 that have ever been production ready. There's JRuby, there's another one written in C++ called Rubinius, and that's pretty much it. Like, no one else has really gotten to the point where people deploy production applications on them, other than JRuby and Rubinius. And we generally beat Rubinius on stuff too. We're actually the only production-ready alternative Ruby that still exists. All of the other ones seem to have been abandoned. It's unfortunate. I really wish Iron Ruby would have kept going. It'd be nice to have the same sort of Ruby implementation for CLR like we have on the JVM side. Still out there. Maybe somebody can work on it. Mm-hmm. Yeah.
If I develop a JRuby project, where should I search for libraries? In Java ecosystem or in Ruby ecosystem? Because yes, once again, I'm asking because I'm practicing with Jython, and they are not compatible with pip modules. Often, if I use pip module, it won't work well in Jython. So
Right.
what about compatibility with Ruby gems, standard usually Ruby gems?
That all works great. You have the full library of Ruby gems out there. Other than things that have been implemented for C extensions for C Ruby will not work. Right, but the vast majority of Ruby gems that are out there are just pure Ruby libraries. We integrate well. Ruby gems works just fine. Bundler works fine. You can use all the Ruby libraries that are out there. Like I mentioned, the case of ASCII Doctor, for example, that uses a ton of Ruby gems, and that works great on JRuby. You can just use either Ruby libraries or Java libraries. That's one of the biggest advantages, and one of the main reasons why people choose JRuby to begin with, because they have the entire library of the JVM available to them as well.
Just yesterday, in one of our projects, we added a dependency to ASCII Doctor.
Oh, yeah.
And it worked fine, just 20 megabytes of extra jar size.
Yep. And actually, we were talking with some folks that had concerns about the size. That 20 megabytes is basically JRuby, all of its dependencies, and all of the regular Ruby standard library. ASCII Doctor probably doesn't need all that. And so we're looking at maybe doing a special way of building JRuby for ASCII Doctor that would cut it in half maybe. So we're just trying to reduce that down. But yeah, it works great. There's a ton of folks out there that are using JRuby without even knowing it.
And native C extension, not many Ruby gems using that.
There's not many. Right. There's not many. It'd be, a few percent of the Ruby libraries that are out there use C libraries. Of those, the most popular ones usually will have a JRuby version. For example, one of the biggest ones is Nokogiri, which is an XML library. In C Ruby, it's a wrapper around libxml. We can't use their API and integrate with that. So on JRuby, it's just wrapping Java XML libraries. And so it's feature compatible all the way across. Most of the time there's a JRuby version. If there's not, there's probably a Java library you can use instead. Or it might be easy to just wrap the Java library and make it look like the C version.
Any surprises concerning performance? Because in Jython, again, I can't use beautiful soup library for web scraping. I have to use JSoup, Java's JSoup.
Okay.
Because beautiful soup in Jython doesn't work very performant. Performance issues with standard Ruby gems.
Okay. So performance-wise, we expect everything to be faster in JRuby than in C Ruby. That's the expectation. If it's not, we very much want to get a bug report for it so we can see why it is. It's almost always something we're doing wrong, something we're doing dumb that we can fix. In general, JRuby should consistently be faster than C Ruby on any Ruby library.
Sounds fantastic.
Yes. All right.
One more question.
Yeah, in the back.
And when I try to move Ruby application that use multi-threading to JRuby, what kind of problem can I expect? Because JVM has like different memory model, and JRuby has a GL, and multi-threaded code in Ruby makes different assumptions about memory and stuff like that.
Yep, yep. So multi-threaded, when you're moving from JRuby to JRuby. First of all, this is one great reason to start with JRuby in the first place, because you're going to find those issues early rather than run into any sort of concurrency issue in some Ruby library. The good news, though, is that because JRuby exists, Rubyists over the past decade have become much more aware of good multi-threading techniques. There are solid libraries out there like Concurrent Ruby, provides mutexes and thread-safe collections and futures and promises and all of those things. Rubyists are actually using it. Rails uses this internally to make sure all of their internals are safe for multi-threading. Again, we generally expect that most Ruby stuff will work fine concurrently with real parallel threads on JRuby. When we find those issues, which it's been fewer and fewer over time, we work directly with the library authors to make sure that they fix their issues, and then we have then we'll help them write better tests for it and make sure that things run. Most of the time, you don't run into it now. I would not have been able to say that maybe 5-6 years ago. You would run into libraries that used a lot of global state and mutated stuff concurrently, and that just doesn't happen as much anymore. All right, I think that's it for questions.
Now we have a break for 15 minutes.
Okay.
We have some kind of пирожки. It's Russian bean.
Sounds good.
And after that we have some demo.
Yeah, I can show a little bit. I've got just a few quick things to show how easy it is to get up and going with JRuby, and we'll do that after the break.
Okay.
Okay, so I didn't have any particular demos prepared, but there are a couple quick things that I can show that I think based on the questions that they'll be relevant. So getting up and started with JRuby is pretty easy. If you do it the standard Ruby way, there is this library called RVM. If you search for RVM, deny. It's basically a way of switching and installing Ruby implementations. So with a little bash script that you run, it installs a command into your environment, and then you get this RVM command. Kind of format's weird there, but RVM install JRuby, and it would go and fetch JRuby and pull it down. I've obviously already got it installed here, but you can install the latest JRuby version, switch between different Ruby versions. A good way, if you're using both standard CRuby and JRuby, you can use RVM to switch back and forth. So I'm already set and using JRuby 9.2. All right, that looks pretty good. Okay, it's cut off one line on the top. I'll keep that in mind. So then once you've got JRuby up and going, then you have your typical JRuby commands. JRuby version gives you information, shows what runtime we're on. We're using regular hotspot here. We've got the JIT on. I showed that InvokeDynamic flag, which should be made shorter maybe. And if that's turned on, it'll show it's running with InvokeDynamic, so you know what sort of performance you're going to get out of it. JRuby, much like Java now has, also has a REPL, a shell that you can go into and play with it. And this is just the standard CRuby shell. This is all the same code that runs in CRuby. It's part of the standard library. JIRB is interactive Ruby, and of course we put a J on everything, so it's JIRB. But once you're in here, now you can do all the standard things you would with Ruby. The fun things, obviously, are with JRuby is that you can start calling into Java libraries. So if we wanted to say Java lang system out print line hello, it just works. I mean, all this stuff just basically looks like if you were calling into any piece of Ruby code. You can Java import java.lang.system. And then you have it available as a regular top-level class or whatever scope you've imported it into. Let's see, what else is fun? I don't know if swing is actually going to survive any longer, but it's a good example of using it. So let's make a JavaX swing JFrame. That looks about right. Looks like it turned it on. Frame.show. Let's see, where is it? There it is. That's not the right size, so we'll do set size 400 by 400. There it is, and that's going to be annoying, so we'll do always. And you'll notice that these methods, so this is the always on top method from Java, or actually in this case it's the set always on top method. We make all the Java methods also work with the Ruby syntax. So we take the camel case and put underscores in. Setters have an equals sign you can use. You can still call the standard Java method name, but we make it fit into Ruby a little bit better. So always on top is true. There it is. Let's see. Oh, I mentioned there was a question about lambdas and integrating Ruby closures, Ruby blocks with Java lambda stuff. Let's do a button. Button equals JavaX swing JFrame.j button. Press me. Okay. Frame dot. I think it's content pane. I haven't done this stuff in a while. Add button. And frame.show, lay it out. Where is it? There it is. Okay. So I mentioned the action listener thing as a perfect example of using a Ruby closure anywhere you'd have an interface or a lambda. So button.add action listener. Let's just do button.text equals you pressed me. And then if this works properly, whoop. So, I mean, just like you can do this now in the Java shell, you can do it with Ruby code, and this is all just calling into regular Java libraries. All this stuff will optimize and work like you'd expect it to. So that's pretty fun. Let's see if I can kill this here. There we go, and exit. Okay, so that's kind of getting up and going with JRuby. If you wanted to get up and going with Rails, you can pick up the Rails book and start basically following along the tutorials about how to use it. Usually the first thing you'll do is gem install Rails. I probably have the latest version installed already, so it may not install a whole lot here. And this is going to go out to Ruby Gem server. It's all just the same gems, the same servers, the same infrastructure for everything. So it'll pull down all of Rails dependencies now. You notice up at the top there, that concurrent Ruby library, this basically came along because JRuby brings real parallel threads to the table. And now Rails and everybody else is using this to make good concurrent threaded code. ThreadSafe is a smaller version of that library I wrote. Here's Nokogiri I mentioned. So on CRuby, this would actually use libxml. Our version is a Java Ruby mix that uses standard Java XML APIs. What a weird, I don't even know what this is, Loofah, crass. But yeah, and then here we have the standard active libraries from Rails. We have Active Record, which is the ORM, and I think, yeah, there's not much else interesting there. So there we have Rails installed. Actually, they had a 5.2.1, so there was a new release, and I got to install all the libraries again. If we want to actually create an application, and hopefully this all works right, Rails new my app, and that will generate all of the baseline application for you, all the base configuration stuff, a bunch of tests. Try and encourage you to always test everything, and then it will run bundle install. Bundler is sort of like what Maven is for dependencies. It goes out and it fetches everything that's needed for a Rails application and makes sure they're installed. And there you see. So there's our version of Active Record. Our version actually just uses JDBC on SQLite, Postgres, MySQL, and so on. But all of the rest of the Ruby code in Active Record is the same thing that CRuby runs. We just have a little bit of a backend for it. What else is interesting here? Most of these things were already installed previously. Multi-JSON. The Ruby Rhino. This is actually There's a version of this that also uses Nashorn, but for doing template compilation, minifying JavaScript and whatnot, Rails uses either a V8 version of this that installs a little V8 extension for JRuby, or a Rhino Nashorn version on JRuby. So again, another thing that's a C extension in JRuby with an equivalent on JRuby that works just fine. And there we have a Rails application generated. Something about deprecation, but we don't care about that. Let's go into my app. And let's see, what should we do? Let's try Rails server. This is using a server in Ruby called Puma. It's just a little tiny command line server that starts it up, gets Rails up and going. Oh, right. So there are a few little tweaks that we have not quite done yet for the newer Rails. There's some libraries that it depends on that for whatever reason it doesn't install on JRuby. It's a minor thing we need to fix. Let's see. Listen. I will just add the listen gem. And I think there was one other one I need to remove here. Maybe they got rid of it. Looks like they might have got rid of it. Yeah, there was another library that we didn't support, and I wasn't sure why they were using it, but you had to remove it from the configuration, but I think that's gone. All right, let's see if that works. Let me do bundle install again just to make sure all the dependencies are lined up properly. It should just need the listen gem. There we go, so now we have listen. Now let's try starting it out. Yep, Puma up here is the server I mentioned. Again, this is another one that would have a C extension on JRuby. I think primarily for the HTTP request parser. They have a little bit of Java code on the JRuby version. But it's the same library with just a tiny bit of code that's different between the JRuby and JRuby. And we're up. So let's take a look. Hey, there. So we got a Rails application running on JRuby. That's all it really took. And it even shows it's compatible with Ruby 2.5, but it's running on the Java platform. So that's pretty cool. Let's see if there's other stuff that'd be fun here. I guess I can show a little bit of actually making Rails do something. So Rails has a whole bunch of code generators. If you've ever used Rails, they basically use the same idea. In Rails, it's called Scaffold. Let's see. So Scaffold has various ways of generating tests, generating active record models, generating controllers, and the whole MVC framework stuff. Okay. Oh, right. I think it's Rails generate scaffold. I don't do a lot of Rails development on a day-to-day basis. You'll notice that there's a classic JVM startup time sort of issue here. We actually have a JRuby flag you can set that turns on, turns off some features in the JVM to make us start up a little better. So I'm going to do that real quick. Dev flag. So let's, actually I'll just copy, we'll do the blog post example that David Hansen did years ago. Rails generate scaffold. We'll have a model called post that has a string title, a text body, and a Boolean for whether it's been published or not. It should start up a little quicker with the dev flag. And then, okay, you can see it generates all this stuff. We've got our database migration for the new table. We have our test information, test fixtures and whatnot. We have our controller and our templates for the different views. And wow, I don't even know what JBuilder is. They're using a name that I've actually did development on JBuilder way back when, but that's not the same JBuilder. I don't know what that is. JSON. It's probably some JSON related thing. And they're using Coffee and Sass and other stuff here. So let's do now. I believe we do rake db migrate. And this is just using SQLite, so I don't actually have like MySQL or Postgres running on here right now. But this will create the database and create this posts table. I could show what the migration looks like. Where is it? DB migrate. So that's the Ruby code that they use to define the table. And the reason that they do it this way, every database change, every model you make in Rails comes along with one of these little scripts. So that at any given time, if you need to go back and investigate a bug in an older version, you just start with a blank database, run db migrate on that version of the app, and it will make all the database changes and roll it forward to the right place for you to start investigating that. So it's kind of a cool feature of Ruby. I've not seen a lot of other frameworks too. So I did db migrate. I think that's all I need to do for development. So let's start up the server again. And this will start up Puma again, and let's go back into our, so that still works. And we go to posts, and we have all of our CRUD operations are right here. Published, create. All right, back, and there it is. So again, this is the attraction of Rails, is how quickly you can get something up and going. Probably not the template, the CSS that you'd want to push into production for an application, but it's a basic app and you can get stuff up and going very quickly. A lot of companies are using Rails to bootstrap, to get up and going. They might migrate to something else in the future, but it's very easy to get a simple application up and going with all the database trimmings and all the features, plus all the JavaScript, CSS, pre-compilation, all this stuff is in there. And it works great on JRuby, as you can see. Let's see, is there anything else to be interesting? Oh, I like their logs. I use ASCII highlighting here so you can see what's going on with it. And Rails Active Record has improved significantly over the years. They have a really good query generator now. They integrate properly with prepared statements so that they can not be compiling them over and over again. So it's getting better. ORMs are notoriously heavy and slow. And Active Record is no different, but it's been improving a lot over time. And let's see, the standard Active Record supports MySQL, Postgres, and SQLite. There is also a separate adapter you can install for Oracle that supports all of the features of an Oracle database as part of Rails. It's called the Oracle Enhanced Adapter for Rails. That works just the same on JRuby versus CRuby. And of course on JRuby they use JDBC too. So whatever database you're on, there's likely a support for it. Okay, is there anything else I can show here? Oh, one more thing I think should work. I haven't used it recently. I mentioned that you can take a Rails application and turn it into a WAR file and deploy it on a standard Java server. The library for that is called Warbler. And I haven't tried this on recent Rails, so we'll see how this works. But gem install Warbler. There is actually a gem we release out into Ruby gems that has all of JRuby inside of it. So this pulls in all of the JRuby dependencies as a Ruby gem. Then I believe I just need to do Warble. And this should fetch, I don't know if it needs to fetch much, most of it should already be local, but it'll pull in JRuby, all of the Ruby dependencies, all of the Java libraries that we need, and create a WAR file. WAR. So that's about a 44 meg, and that's including Rails, JRuby, all the Ruby gem libraries, everything that you need for this application. And I believe, this one I really haven't tried. Let's see if this works. It's also an executable jar. Oops, no, not that one. So there's another command I don't remember offhand. But you could also have it just generate an executable jar, and then it includes a little tiny web application server in there, so you can just execute it and have a freestanding single file Rails application with all the dependencies right inside of it. Let's see if that's in here. Execute. There's a lot of commands. All right, I can't find that now. You can trust me. There is a way to do it. I don't remember it offhand. Yeah, okay. But yeah, like I say, we have had people that would actually take this, this warbler, turn a Ruby application into a WAR file and deploy it into production without anybody ever realizing they were running a Ruby app. And of course, you can deploy it alongside your other apps. You can call into all the Java libraries. I believe, so there's the gem file that I was looking at before. This is where all of the Ruby dependencies are specified. We support an additional syntax in here so you can say all of the Java libraries that you need. And then Bundler will also go fetch those Java libraries, pull them down into your application, and the same way that it does all the Ruby dependencies. So we really try to fit into the way Rubyists work. They use this standard little server called Puma, they use the gem file, they use Bundler, and everything works exactly the same way on JRuby. All right. I think that's about all I have for simple demos I can run right now. I can show, let's see if I can find that. Projects, bench 2018. Bear with me for a second. I've got the Mandelbrot generator here. And so for benchmarking purposes, it's been modified to not actually print anything out, but I think it's kind of fun to see it do it. All right, let's run it. Oh. Okay, I forgot this one actually generates PNG. Let me see. Something. I don't know what it is exactly. But it's going to generate a bunch of times. I have another version of this that's a little less, that actually prints out on text version. I'm not sure where that is. And .JRuby. No, I can't find that one. Let's just do, let's try that. Data, that's helpful. Yeah, I don't know what format they put this in. It's some image format that I don't know how to open. Open file, that's something. Let's see what happens. No, okay. Well, so I won't be able to show that. But hopefully you can see it's pretty easy to get up and going with JRuby. Like I say, for Rails or for Ruby itself, you can just walk through all the same tutorials, the same commands should work, the same libraries should work. We've done a lot of work to make sure that things are compatible and run the same way. So I think that's about all I have for demos. Any other questions? Yes?
Have you have any tooling based on Maven or Gradle for JRuby?
Yes, we do. For Maven, there is, so let's see, there is also a Gradle plugin as well for doing JRuby stuff. I don't know how complete it is, but at least for pulling in JRuby and gem dependencies and whatnot as part of an application, that does exist. On the Maven side, we have the ability to specify gems as dependencies within a Maven build. We also support, we've also done a lot of work to help support the polyglot Maven extension that allows you to write Maven files in other languages. And actually, our Maven file is a Ruby version. It's actually a Ruby code that generates the pom.xml and whatnot. So you can use Ruby. I think there's a couple others, YAML, JavaScript. I think there's a Groovy one. So that's all based on JRuby. But yeah, as far as integrating JRuby into an application and pulling in all the Ruby dependencies, we do have that support, and there are plugins for it. Another good place where folks start using JRuby, if you're an existing Java app or existing Java ecosystem, is for testing. It's much easier to write tests in Ruby because you can actually write a test for a class that doesn't exist. it'll all fail, but then as you add methods, things will start to turn green. You can test first, really, which is almost impossible to do with writing tests in Java. It just won't compile if the class doesn't exist or the methods aren't there. And we have plugins for Maven and I believe Gradle that you can just write your tests in Ruby for your Java application, which is a much cleaner way of doing it. And it's an easy way to start getting some JRuby experience and playing around with it. You saw it was very simple for me to call into Java code. It's just as easy to start writing tests the same way. And you can use the standard Ruby test frameworks like RSpec, which is a fun one. Let's see, spec, Java integration. Let's see what's a good one. Methods. Let's just do look basics. I'm going to shrink this down a little bit. So this is what RSpec syntax looks like. It's a specification driven more than writing individual tests. So this is saying Java instance methods have the correct arity when we look up their arity or see how many arguments they have. Overloads properly. Static methods do the same thing. Logic for some extensions we add to the class. But a different way of doing testing, a more efficient, cleaner way of writing tests that the Ruby folks really like using. You can use that to write tests for Java applications just the same. Any other questions? Yeah?
I wonder, what do C-Ruby developers think about JRuby? Did you have any conversation?
So C-Ruby developers, as in the people that work on C-Ruby, we're actually very good friends with them. In Japan, where C-Ruby is from, and the majority of the developers are Japanese, JRuby is known as C-Ruby's little brother. So we are very close. We're very friendly with all the core Ruby folks. I'm actually a committer to C-Ruby as well, although I mainly like tweak tests and fix some of the Ruby libraries. I don't touch most of the C code. But we work very closely, and you know it's tough because sometimes I'll be at a Ruby conference and Yukihiro Matsumoto, the creator of Ruby, will be sitting in the front row while I'm talking about how much better JRuby is. And I'm always like, yes, I know, thank you for making Ruby, and yes, sensei, and it's a very good project, and I know, no disrespect, sir, but we are much faster, and we do things much better. But yeah, there's really no bad blood at all. We're very good friends with the C-Ruby folks. Anything else?
Does any IDEs have syntaxes support for JRuby, like IntelliJ IDE or
Yep.
Eclipse?
Yeah, if you're using IntelliJ, that's probably the best one. There is a separate Ruby IDE that they have called Ruby Mine, I think it is. But essentially, if you install IntelliJ and tell it to install the Ruby plugins, you get all that support. And it's actually pretty solid. Doing IDE support for dynamic languages is notoriously difficult, but their code completion, refactoring, almost all that stuff really does work well for Ruby code. We all use IntelliJ to develop JRuby largely for that reason, because the Ruby integration is so much cleaner. There are also plugins for, there's a plugins for Eclipse. I'm not sure if those are being maintained anymore. And NetBeans, there is a Ruby plugin that actually is based on JRuby, and I think we maintain that now, or at least Tom, the other JRuby guy, he maintains that plugin. So at least for the three major IDEs, there is support. IntelliJ is definitely the best one now. It knows about Rails applications and how they're structured and how the generators work, all that stuff.
They use NoSQL DBMS with JRuby, and what's the name of this NoSQL DBMS?
Well, I mean, you can use pretty much any one of them. There are Ruby libraries for MongoDB, for example, and all the other ones. Similarly for messaging, alternative messaging systems and in-memory caches, like there's memcached libraries for Ruby that work just the same on JRuby. So pretty much anything that's out there, some Rubyist has used it and written a library that you can run with JRuby too. And even beyond that, if there is a MongoDB support for the JVM, you could just use that. You can just call into those libraries like any other piece of Ruby code. So you get all of them from both sides. Anything else? One more.
In future, can I build a model Java 11 in JRuby and use it in native Java application?
So like an active record model that you build in Rails and then want to be able to call from Java or use it from Java. It might be possible. I think you would need to have the best way to integrate a piece of Ruby or a Ruby class into a Java application directly would be that you implement some interface. So you would at least need to define the Java interfaces that correspond to whatever the model fields and whatnot are. But at that point, if you stick that into your active record model and generate the code, it should work. It should actually look like those interfaces, and you could pass the Ruby model right back out to Java. I don't know of anybody doing that. I don't know if I'd say recommend, but I probably would recommend if you were going to use the same model in both Ruby and in Java, it'd be better to stick with a Java-based model just because the requirements static typing-wise are easier to fulfill if it starts in Java. Yep. All right.
You said that there is only 2 developers involved in this?
2 full-time developers, yeah. We have a number of folks that do, they do a lot of free contribution, open source contribution. There's at least a few folks that do contract work, so like individual bugs. If we don't have time to get to it, you can hire them to do some work on it. They do contracting and whatnot. So there are, some dozens of people that contribute to JRuby, but just the 2 of us full-time on it. And we've been lucky to be able to be full-time for the past 12 years on JRuby, so. Thank you, Red Hat. Buy Red Hat, buy Red Hat. Red Hat's great.
What does Red Hat get from it?
That question always comes up. I'm not really sure. So we work in this research group, and we work very closely with Red Hat's OpenJDK team. We work closely with Oracle, Java folks. And so JRuby is an interesting and difficult project that has a lot of side effects. Getting the JVM to do dynamic languages better, getting the JVM to support native libraries better. All of this stuff has really started because JRuby exists. Another way that we actually help, there are some projects within Red Hat that are Ruby based. Currently they're running on CRuby, but we're working with them to try and transition it over, especially as they become more, they move into a product phase and they actually want to release something. A lot of Red Hat users are also JVM Java users that would want to run on the JVM instead. So we're working with those teams. The final thing that I think my boss's boss's boss has said is that Red Hat doesn't want to become an IBM where all we do is business software and none of these other cool things, side projects. So we are kind of a side project to help keep Red Hat cool. And that's okay. I can go with that. All right. Well, thanks very much for coming out. You can contact me on email, headius@headius.com. Same thing on Twitter, @headius, Headius. And check out JRuby and let us know what you think. Thanks a lot.